Yes. Hello everyone. Good evening to all of you guys. I hope all of you are doing well and good. Okay. Okay. So today is the actually seventh class is going on in functions also. You know, I don't know. Okay. So uh, in this class, what are the concepts or what are the things we'll cover? Uh, we'll learn what is periodic function, you know, how we can evaluate the period of functions, different types of functions also, any functions also, and we'll see types of functions like one function, onto function, many one functions, into functions, bijective functions, and also finally in the end of the class we'll not in the end, and we'll learn what is composite function. Okay, what is composite functions? So before going through all these things, in the last class, I gave you one homework questions. So my question is, how many of you solved that questions and coming here with the solution? Can you respond in the chat box? What is the answer of these questions? How many of you got the answer of this question? Can you please respond to the chat box, everyone? Guys, in the question it is asking, the given function is what type of functions? Is it odd function or is it even? It is even. It is odd or even or neither, or it's a constant. What is the answer? Anyone can answer this question, guys? Anyone can answer this question? My voice is clearly audible to you all, guys. Zoom, YouTube, everyone. Is my voice clearly audible to you all? Yes. I hope yes, because in my mobile also I can hear me. ठीक है. Nobody did this question. चलो ठीक है. I will solve. Let's solve. So this is the question and solution. What is happening? F of x is given as sine of x to the power 7 into e to the power sine of x to the power 7 or sine की power. So sine of x to the power 7 into e to the power, is it sine of x to the power 7? Okay, let's see. ठीक है, e to the power x to the power 5 into signum function of x to the power 9, है ना? Signum of x to the power 9. So now we need to verify, we'll verify whether it is an odd function or it is an even function. This is the thing. So how we can verify whether it is odd or even? What are the conditions to verify the function is even or odd? The important even के लिए क्या होता है? Even, the condition is f of minus x gives you, if it gives you f of x, right? And for odd, what is happening? There is some problem with my pen. Okay, f of minus x, if it is giving you minus of f of x, right? Then we can say this function is odd function. Is it or not? Just a minute. Why my pen is not working? Let's see now. Yeah. Okay. So these are the conditions for even and odd functions. Now, in the given questions, we'll put in place of x, we'll take minus x, right? F of minus x, right? Okay. So this will be sine of minus x to the power 7 into e to the power minus x to the power 5 into signum of minus x to the power 9. Is it or not? Yes. Like the function is, oh, yes. Okay. Let's see. Sine of minus x to the power 7, minus x to the power 7 is minus into x to the power 7. We can write this as sine of minus of x to the power 7. Yes or no? We can write or not? And here we can write minus of x to the power 5 into signum function is odd function. है ना? Signum, this function will be odd function. This will be odd function. So we can write this here minus of signum of x to the power 9, right? So minus into minus will be plus. So all of you know sine of minus x is minus of sine x, right? So sine of minus x is minus x. So sine of minus x to the power 7 is minus sine of x to the power 7 into e to the power minus into minus will be plus e to the power x to the power 5 into signum of x to the power 9, right? So now we are getting minus of f of x. So finally we are getting here f of minus x is equal to minus of f of x. So what is the condition the given function is satisfying? It's an even function or odd function? It's an odd function. Yes or no? It is an odd function. So answer is it's an odd function. Clear everyone? Anyone having doubt? कोई doubt है इसमें? So answer is correct option is A. Clear everyone? Any doubt in this question? कोई doubt है इसमें? Guys, कोई doubt है इसमें? Any doubt? You can ask. Okay, Zenbi Nolo, thank you. Okay, let's move to the next thing. Now, the new thing is the periodic function. So what do you mean by period? Periodic function होता क्या है? Period क्या होता है? Basically, you can say, sir, it's a time interval. It's related to time, basically, right? है ना? So periodic function. What is periodic function? We'll learn that. ठीक है? So by using an example, we'll understand what is periodic function. ठीक है? So when we can say a function is periodic, the condition is like as previously you have studied some conditions for even function, one condition for odd functions also. For here also for periodic function, a function to be periodic, when a function can be periodic, there is a condition, right? So if you have a function f of x, it is said to be periodic of x if there exists a positive real number t. If there exists a positive real number t for which this condition function is satisfying this condition. That means f of x plus t gives you f of x. Then the smallest value of t, the smallest value of t is called fundamental period of the function. What is called? What it is called? Fundamental period of the functions. Forget about all these things. Now understand this by using one example, right? Here in the on your screen you can see you have one example, like you have a function f of x is equal to sine x, right? F of x is equal to sine x. So if I will ask you, is it periodic? Is this function periodic? Your answer will be yes. Sir, it is periodic. How you know it is periodic? How you know it is periodic? Guys, how you know it is periodic? Because in the graph also you can see or you can observe, if I am starting my graph from 0 of sine x, if I am starting the graph of sine x from 0 or from origin, it is starting from here, okay, and goes towards this way and reaching this point, right? This is reaching this point. So you can see when the graph is starting from origin and goes towards pi 2 pi and reaching the point 2 pi, so in between 0 to 2 pi, for the values of x 0 to 2 pi, what are the values of y you are getting? What are the values of y you are getting? These red curve, these values you are getting in between 0 to 2 pi. Okay. Again you are starting, to getting all those values from 2 pi to 4 pi, in between the interval 2 pi to 4 pi. That means the graph repeat itself after each 2 pi intervals, right? The graph here, the graph is repeating itself after each 2 pi intervals, right? So here the graph is starting from 0, again the graph is starting from 2 pi. You can see again the graph is starting from 4 pi. The same graph repeat itself again and again after each 2 pi interval, right? So that's why this 2 pi is called the period of the function y is or f of x is equal to sin x. Is it clear to everyone? You can ask, sir, we can say the period is also 4 pi. Period can be 4 pi here also. You can ask. Yes. The answer will be yes, obviously. Because after you can say also, or you can see also, after each 4 pi interval, the graph repeat itself. After also 8 pi intervals or 6 pi intervals, the graph repeat itself. So you can say all these are period. You can say period, but they are not fundamental period. What is the fundamental period? Now the smallest positive values of t. The smallest positive values of t. What is the smallest? What is the smallest value of t for which the graph repeat itself, or the values of function repeating itself, repeating themselves? Bolo, that is 2 pi. 2 pi is the smallest interval for which the graph repeats itself. 2 pi is the smallest interval for which the values are repeating themselves, right? That's why t is the fundamental period, and here the fundamental period is 2 pi. The 2 pi period, the sin x, the period, generally we are saying fundamental period as period, and period of sin x, the period of sin x is 2 pi, right? Period of sin x is 2 pi. Or we can say sin x is a trigonometric function which is 2 pi periodic, right? 2 pi periodic we can say. And here we can say the fundamental period. Fundamental period is 2 pi. The important thing is, remember, the important thing is here, t is the smallest positive integer, positive real number. T is the positive real number, smallest real positive real number, right? For which the graph or the function repeat its values again and again. Okay? Clear everyone? Please respond to the chat box if it is clear to all, guys. Please repeat. Please, anyone having any doubt, you can ask also. Janvi Nellore, is it clear? Mansi, other Janvi also, is it clear to all? What is fundamental period? What is, how we can find the period also? How we can visualize the period of a function by using the graph? Clear? Any doubt here? Any doubt you are having, you can ask. कोई भी doubt हो तो पूछ सकते हो. और भी बहुत सारा concept है इसके ऊपर, जाएंगे धीरे धीरे, don't worry. Period of sin x squared and sin 2x. Period of sin x squared and sin 2x. Acha, you are asking sin square x. Okay, we'll go through that. And you are asking the period of sin 2x. We'll go through that. Don't worry. ठीक है? You are asking that na? Period of sin square x. Okay, we'll go through that. Don't worry. Now, there are some, we can say rules. है ना? If f of x is a periodic function, suppose we are saying my function is periodic. Already we know it's a function which is periodic with the period t, whose fundamental period is t. With the period f of x is a function with the period t, then if you multiply constant k with the function f of cx plus d, है ना, अगर if f of x is a function which has the period t, then k into f of, in place of x we are taking cx plus d, in place of x we are taking cx plus d, right? If you write x as in this format, and k into f of cx plus d has also the has period t upon this t upon mod of c, that is c. What is c? The coefficient of x, right? Coefficient of x. In the chat box you asked what is the period of sin x. Here see, y is equal to, or we are taking f of x is equal to sine of 2x, right? F of x we are taking sine of 2x, is it? So what is the period of sine of 2x? We know sine x is periodic, okay, which has the period 2 pi. Sine x is 2 pi periodic. So here my f of x is sine x, right? And my here we are having another function, that is f of x is equal to sine of 2x. So the base function is sine x. Sine x is periodic, and which is the period as 2 pi. Then sine of 2x will be, here k is 1. I am taking k as 1 into sine of cx plus 0. C is 2. Here c is 2, k is 1, and here t is 2 pi. Okay. Then the period of sine 2x will be what? The period of sine 2x will be what? It will be, that is 2 pi upon the coefficient of x, that is mod of 2, which is pi. Is it? Sine of 2x, yeah, है ना? ठीक है, clear? So sine of 2x will be having the period that is pi. Similarly, you are asking this, is it clear? JNB Nellore, is it clear? Clear or not? Yes, it is clear. Yes. Then come to the another rule, right? If f of x has a period t, right? If f of x has a period t, similarly, some function you are having, that is f of x, which period is t, then 1 by f of x and under root of f of x also have period t, right? If f of x is a periodic function which has period t, then 1 by f of x and under root of f of x also have a period t. It's another rule also, right? Remember these two rules. Please note it down or take a screenshot also. Please note it down, right? These are few rules. Okay. Now we'll go through another rules, right? I hope my screen is not visible to you properly. I'm switching off my video for few minutes. Okay. Okay. Now, if f of x has a period t1, you have two functions. One is f of x, another one is g of x. F of x has the period t1, and g of x is another function which has the period t2. Then period of, remember, period of f of x plus or minus g of x, f of x into g of x, f of x upon g of x is LCM of t1 and t2, provides their LCM exists, right? The important thing is, if LCM of their period is exist, then we can say the period of f of x plus or minus g of x, or f of x into g of x, or f of x by g of x is LCM of t1 and t2 if f of x and g of x, if g of x are having the periods t1 and t2 respectively. Is it clear to all? However, that LCM if exist need not to be fundamental period. If LCM is exist also, there is one more condition. अगर और मैं बता रहा हूं कि अगर LCM एग्जिस्ट कर जाए फिर भी ये इंपॉर्टेंट नहीं है कि ये नेसेसरी नहीं है कि उसका ये फंडामेंटल पीरियड हो जाए. इफ LCM does not exist, then it is non-periodic. Simple. If LCM does not exist, then that is the LCM will not be a period of those two functions, sum or product or division of those functions. Okay, clear? ठीक है. Like we'll take some examples also. Don't worry. ठीक है. Like in the last question, I got one question that is f of x is equal to sine square of x. So what is the period of this function sine square x? What is the period of the function sine square x? Right? So you can say, sir, the period of this functions will be 2 pi because if you'll add x plus 2 pi. So sine square of x plus 2 pi will giving you also sine square of x. Yes, no problem. Right? Because is it or not? Okay. Now, again, what is the, if I ask you what is the period, think about it. Is there any other small positive number, positive real number for which sine square x will repeat its values or will repeat its graph also? Is there any smallest positive real number for x which will be added with x and sine square of x plus that number will give you sine square x? Is there any smallest positive number which will be lesser than 2 pi? Is that? अच्छा, तो मुझे ये बताओ तुम, पाई बाई 2 हो सकता है क्या? आई एम गिविंग हिंट्स. पाई बाई 2 हो सकता है क्या? इज पाई बाई 2 इज द पीरियड ऑफ साइन स्क्वायर एक्स? 1 मिनट, बोलो. यस, एनीवन इज गेटिंग द आंसर? नो, पाई बाई 2 नहीं हो सकता है. तो साइन ऑफ, इफ विल पुट साइन ऑफ एक्स प्लस पाई बाई 2 which is giving you cos of x, na? Cos of x, and again if you square it, cos square x you will getting. So no, pi by 2 is not. So is pi is the period? Pi is the period? We can say pi is the period or not? Pi can be the period of the function sine square x or not? Sine of x plus pi gives you what? What? Sine of pi plus x. What is it? Comes to the third quadrant, which where sine is negative. So minus sine of x you are getting. Is it or not? Minus of sine of x you are getting. So when we are squaring it, we'll get positive. So sine square x you are getting. Yes, sine square x you are getting. So pi is the period of this function sine square x. So sine square x is pi periodic. You can also observe from the graph. This is the graph of sine x, right? When we are squaring something, that means all the value will be positive or not. All the value will be positive or not. If all the value becomes positive, then this portion, negative portion, will be coming to this side, will be positive or not. So you can see this is my 0, this is my pi by 2, this is my pi. This is my pi, sorry. This is pi, this is 2 pi. So all here from the graph also you can observe the graph repeat itself after each to pi interval, each pi intervals. So that's why the period of this function sine square x is pi. Is it clear to everyone, guys? JNB Nelo, is it clear? Done? Is it done? Clear? Draw the graph of sine square x. Okay, when you are squaring something, that means you are getting positive values. So the graph, the negative portion, the negative graph present in sine x, when you are squaring, those graph will be, those negative value will be positive or not. When they becomes positive, then you are getting the graph, those are what, which period is pi. Also from here also you can see sine of x plus pi is minus of sine x, right? Minus of sine x, and again sine of x plus pi is minus of sine. So minus of sine x into minus of sine x is sine square x. So you are getting again f of x, and for x is equal to pi, you are getting the repeating values, right? Again you are getting the f of x, right? The period of sine square x is pi. Is it clear to everyone, guys? Clear? Guys, clear or not? Zenbin Elore, is it clear? You have asked. So will LCM rule apply if f of x and g of x are equal? Oh, how, what is the need? What is the need actually? So when what we are doing, when you are multiplying, when you are multiplying some constant, suppose you are adding two functions, equal functions like sine x plus sine x, you are getting 2 sine x, right? So what is the period of 2 sine x? Sine x is 2 pi periodic, right? Sine of x is 2 pi periodic. Simple. So like sine square x, sine square x is pi periodic. Sine square x is pi periodic. You are saying if f of x and g of x are equal, that means you are taking two equal functions like sine x and sine x. Okay, f of x sine x into sine x. No, 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 no. Yes, you can take f of x into g of x also. Okay, okay, okay. Equal functions you are taking, like sine square x into sine square x. देखो, the basic rule is, the basic definition is, the main definition of, actually the main definition of periodic function is this, है ना? Here we have discovered some rules, है ना? It may be, it will be working some in some cases, but in some cases also it can't be work, है ना? Because here, like when you are like one function, like in one function also you will face such type of questions. Okay, so when you are when this rule is working, 2 pi is the period of sine square x. Yes, after 2 pi period, after 2 pi interval, sine square repeat its values again and again, no issues. 2 pi is the period, you can say. But what is the fundamental period? Fundamental period of sine square x will be, because pi is a real number which is lesser than 2 pi, for which sine square x is also repeating its values again and again, right? There is a other positive real number exists which is less than 2 pi, which is less than 2 pi, for which the condition or the definition of periodic function is satisfying by the function f of x is equal to sine x. That's why the period of sine square x is sine to pi. Is that clear to everyone? Clear? The important thing is definition, but these are some rules, right? These are some rules. They may be work, they may not be work, right? Okay, chalo, let's move to the next questions. Actually we have a lot of syllabus, actually, guys. If we'll discuss, it's good actually. It's actually interactive, and I'm feeling good to clear for clearing your doubts. When you are asking doubts, it's good also. I'm feeling good. but we are having very less time and we are having a lot of syllabus need to cover. We need to cover those things. Okay. So let's come to the next thing. These rules will be working, but except these functions, there are some few functions. There are few functions for which this rule will not be work. Like period of f of x, period of mod of sin x plus mod of cos x, right? Mod of sin x plus mod of cos x. You can say here pi by 2. What is the period of mod of sin x? You can take, we can take here. Dekho, f of x is mod of sin x plus mod of cos x. So if we'll apply the LCM wala rule, so what will be the period? Here the period will be LCM of 2 pi and 2 pi is 2 pi. You can say, sir, the period is 2 pi. No, because here mod of sin, what is the period of mod of sin x? All of you know what is the graph of sin x? Yes, the graph of sin x is like this. Okay, the graph of sin x is like this. Okay, but when we are taking mod, these negative graph will coming upwards. These negative portions will be coming upwards. Then the period of this sine of mod of sin x is pi, and also period of mod of cos x is also pi. So LCM of pi is pi. Okay, the LCM of pi is pi. But for 2 pi also it will be working. Okay, but the smallest positive number, the smallest positive values of x, which is pi, for which f of x plus t is equal to f of x will be working. Definition works for this period pi, right? So the correct answer is pi. The period of mod of sin x plus mod of cos x is pi. Clear everyone? Clear? Chalo, ठीक है. Let's see another example here. You can, अच्छा मैं ये तुम दोनों को, तुम लोगों को ना वेरीफाई करने के लिए दे देता हूँ. Next two functions, period of this f of x sin की power 4x plus cos की power 4x is pi by 2, and mod tan of x mod of cot of x is pi by 2 instead of pi. So take these two as your homework and verify these two and come to the class with the answers. Clear? Chalo. Okay, let's move some other rules. Chalo. Now on your screen you are having some functions like sin की power nx, cos की power nx, sec की power nx, cosec की power nx. When n is even, the period of all these functions, if the power of all these trigonometry function is even, the period is pi. If the power is odd or any fraction, if the period power n is odd or any fraction, then the period will be 2 pi. Remember, okay? If the power this n are even, then the period is pi. If they are odd or any function, then the period will be 2 pi. Right? Tan की power nx and cot की power nx. It is pi, they are pi periodic when n is either even or odd. Either even or odd. कोई भी हो, or हो, odd हो या even हो, the period is pi. Remember, tan की power nx, cot की power nx. In these two functions, whatever may be the powers, है ना, irrespective of even or odd, the period is always pi, right? Mod of all these trigonometry functions, when we are taking mod of trigonometry function, the period will be always pi. And remember, the period of x minus greatest integer of x, that is fractional part of x. All of you know what is the graph of fractional part of x? That is 1 unit, right? Period is 1. Fractional period of fractional part of x is 1. Okay, clear? So let's move. Now there are few questions for you. what is the period of f of x is equal to sin x plus fractional part of x. Okay, now tell me, you have 20 seconds. What is the period of f of x is equal to sin of x plus fractional part of x? All of you know what is the period of sin x and what is the period of fractional part of x. I am waiting for your response in the chat box. Please respond to the chat box with the answer. Everyone, please be participated in the class here. Be interactive. Answer the question. What is the answer? All of you know, na? When you are having f of x plus or minus g of x, if f of x is having the period t1 and g of x has a period t2, then period of this function is LCM of t1 and t2. So what is the answer for this question? Sin of x, period of sin of x is 2 pi. Fractional part अभी डिस्कस किए हम लोग. What is the period of fractional part of x? That is 1. So what is the period of sin x plus fractional part of x? That is LCM of 2 pi and 1, which is 2 pi. Is it or not? Clear, everyone? It's wrong, guys. It's wrong. Okay? It's wrong. The period, it's not a periodic function. It is non-periodic. It is non-periodic function. Why? Why? Because period of sin x is 2 pi. Period of fractional part of x is 1. 2 pi is an irrational number and 1 is a rational number. So LCM of any irrational number and rational number is not possible. Okay, is not possible. Okay, if LCM does not exist, we know period, the function is non-periodic. Guys, the function is non-periodic. It's non-periodic. It's wrong. Clear? Clear, everyone? Okay, if it is clear, come to the next question. If you are having any doubt, just write your doubt in the chat box. कोई भी doubt हो तो पूछ सकते हो, है ना? पूछ लो. The period of f of x is equal to sin of x by 2 plus sin of x by 4. It is easy. It's an easy question. Yes or no? Can you please respond to the chat box with the answer? It's a very easy question. Guys, please respond. अच्छा, ठीक है. So we know what is the period of sin x. Sin x की period होता है, that is 2 pi. What is the period of tan x? Tan x की period होता है pi, right? So we know if f of x is a periodic function which has the period as t, then k into f of cx plus d has the period t upon the coefficient of mod of coefficient of x, right? So here we know sin x की period 2 pi है. The period of sin of x by 2 will be 2 pi upon coefficient of x, that is 1 by 2. Okay, LCM of this and tan of x by 4 की tan x की period होता है, that is pi. Period of tan x is pi. So period of tan of x by 4, that is pi upon coefficient of 1 by 4 x. What is 1 by 4, right? So that is LCM of 4 pi. Is it or not? LCM of 4 pi and 4 pi is 4 pi or not? So what is the period of this function? That is 4 pi. Clear? Clear, everyone? Guys, clear or not? Yes? Clear. Chalo. ठीक है. Let's move to next thing. Now we'll learn what is 1-1 function or injecting function. है ना? 1-1 function. What is 1-1 function? Simple है. चलो. ये function f which is mapping from a to b is said to be 1 1 function or injective mapping if different element of a have different image in set b. Okay, chalo koi nahi, we'll use or we'll understand this by using this Venn mapping diagram. Okay, chalo let's understand. F is a function which is mapping from the set a to b, which is mapping from set a to b. How we can verify whether this function is 1 or not, 1 1 or not? The definition is saying the different element of set a is having different image in set b, then we can say the function is 1 1. That means the set, what are the elements the set is having, set a is having, so those elements are having different image in set b. That means here we can say, in the figure also you can understand, a1 a2 a3 a4 are the elements of the set a. So a1 is having, b1 is the image which is present in set b, which is the image of set which is the image of a1. Okay, similarly b2 is the image, b2 is the image of a3. Okay, b3 is the image of a2 and b4 is the image of a4, right? So all the elements of set a having different image in set b. Clear? Then we can say this function is 1 1. Okay, other method to verify whether the function is 1 1 or not. Suppose you are having a function f of x like this, then in place of x take x1, f of x1 and equate with f of x2. If you are getting finally x1 is equal to x2, then also we can say the function is 1 1, right? Then we can say also the function is 1 1. Clear? Clear everyone? Clear na? Okay, chalo. Now tell me f of x is equal to x square. Okay, it's a function. ठीक है, is it 1 1? Can you tell me, is it 1 1? f of x is equal to x square, is it 1 1? Not 1 1. Why it is not 1 1? Why it is not 1 1? If we'll take f of x1 is equal to f of x2, we are getting x1 square is equal to x2 square. If we'll take on root on both sides, square root on both sides, then we'll get x1 is equal to x2. Why it is not 1 1? No, it is not 1 1. In periodic function, we have faced such type of similar type of problems. Okay, it is not 1 1 because it is violating our definition of 1 1 function. Why? You can see here. If I'll ask you, what is the value of, if the function is f of x is equal to x square, what is the value of f of minus 2? That is 4. What is the value of f of 2? We are getting 4 also. So for for different values of a, for different elements of set a, for different element of set a, you are getting same images in set b. You are getting same images for in set b, है ना? For different values of x, you are getting same values of y. That's why it is not 1 1. That's why it is not 1 1, because it is violating our definition of 1 1 function. Is that clear to everyone, guys? Clear? Why it is not 1 1? Why it is not 1 and it is clear to everyone? है ना? And also we'll see another method. Okay, don't worry. If it is clear, let's move to the next thing. Okay. Now, another method also I am explaining here. Let's see. horizontal line test. Horizontal line test. Okay, so same example I am taking. F of x is equal to x square, right? So draw the graph. So this is the graph of y is equal to x square, parabola. Yes or no, guys? Is it or not? See, if I'll take, okay, by the definition, when you are taking -2, when you are taking 2, we are getting same values. We are getting same values, that is 4. Yes or no? That is 4. So always remember, any function is given to you. If you know the graph, you can easily verify that function is 1 or not, right? Always remember, if we'll draw any graph, suppose here we are having the graph y is equal to x square. If we'll draw a horizontal line as making parallel to x axis, okay, suppose I am drawing this graph. If the horizontal line intersecting the graph of the given function at a single point, then that function is called 1. If it is intersecting more than 1 point, make note of all these things, more than 1 point, then it is not 1. Right? It is not 1. So that's why here you can see the horizontal line intersecting the graph at 2 points. Here also you can say the horizontal line intersecting the graph at 2 points, more than 1 point. That's why this function is not 1. If you know the graph of the asked question, the graph of any function, okay, then you can verify easily whether that function is 1 or not. Is it clear to everyone? Guys, shall we move to the next thing? Guys, is it clear? We have a lot of bolo jaldi. Is it clear? Bolo jaldi. Yes. Chalo, ठीक है. If it is clear, let's move the next thing. Okay. From the following, from the given graphs or mapping diagram, anyone can say, where is my pointer? Oh, is it blue? Chalo. From the given mapping diagram, anyone can say which of the following are 1 or many 1. Many 1 means those are not 1, right? Those are many to 1, not 1 to 1. First is 1 because each element of set A are having different elements in set B. Okay, but in the second example, you can observe all the 3 elements of set A are having a single image in set B, are having the same image in set B. That's why it is not 1, it's many 1, many to 1. Here we are getting mapping is 1 to 1, but here we are getting many to 1. Clear? Similarly, in the third example, it is many 1 because the element set A and B, the elements A and B are having same image in set B, right? 1. Okay, that is, if it is a function f which is mapping from A to B, so f of A is equal to f of B we are getting, which is 1. So that's why which is well violating our definition of 1 function. That's why it is not 1, it is many 1. It is many to 1, right? Here also it is many to 1. Clear? It is many to 1 function. Okay, so this is all about your 1 function. Let's move. Okay, these are few things already we have discussed. Any continuous function which is entirely increasing or decreasing, then the function in whole domain is 1. Like we have already discussed these things by using the graphical method. If the function is either increasing or decreasing. Then if we'll draw a horizontal line, it will be intersecting the graph at a single point. It will be intersecting at the graph of at a single point. Then the graph will be, then the function will be 1, 1. Simple, right? Second thing is saying continuous means if you can draw the graph without lifting the pen, right? And if that graph is entirely increasing or entirely decreasing, then those graph will, then those function will be 1, 1. Okay. Second thing, if a function is 1, 1, any line parallel to x-axis covers the graph of the function at most 1 point. Okay, at most 1 point. Then always remember, in case of all the one graph of all 1, 1 functions, if you draw the horizontal lines parallel, making parallel to x-axis, those parallel lines or those horizontal lines will be intersecting to those graph at a single point. Okay, the function which is not 1, 1 is many to one functions. Already we have discussed. Let's move. It is many one, already we have discussed. It is 1, 1. It is 1, 1. If we'll draw a horizontal line, it is, we are getting, it is intersecting the given graph at a single point. It is also 1, 1. Okay, clear? This is the horizontal line test of 1, 1 function. Now, what is onto function? Onto, what is onto function? Onto function, when if a function you are having, f is mapping from A to B, set to be onto, if range is equal to codomain. Codomain is given here B. If you are getting range set as also B, range set is also B, then we can say that function is onto, right? That function is onto function. Clear? Okay. Here in this example also, set A is having the elements 1, 5, 8, 9, and set B is having the elements 2, 4. So here the range set is, what is the range set? We are getting range set is 2, 4, and already codomain is given as B set. Codomain is also 2, 4. So range is equal to codomain. Range is equal to codomain. Then we can say this function is onto. If you are getting in a function range is equal to codomain, then we can say that function is onto function. Okay, let's discuss more examples. Okay, this is okay. Remember, when you are getting range set same as codomain set, that function will be onto. So how we can check onto function, that is important. We'll discuss, don't worry. Let's see. What is bijective function? What is bijective functions? Okay, when a function can be said bijective. Okay, if f is a function which is mapping from A to B, it is said to be bijective if it is both 1, 1 and onto. If a function is 1, 1, both 1, 1 and onto, then those functions are called bijective functions. When the function is 1, 1 and also onto, then we can say that function is bijective function, right? Here we can see it is 1, 1 because the mapping is 1 to 1. Okay, the elements of A are having the different images in set B, then it is 1, 1. Onto, why it is onto? Because the codomain is B and range set is also B. What is range set here? Range set is the set of images, that is 2, 4, 7, and also it is codomain. It is given. So that's why range is equal to codomain. So it is onto also. It is 1, 1 and also it is onto. Then we can say it is bijective, right? It is bijective. Clear, everyone? So already we have covered what is 1, 1 function, many one function, that is bijective function. Now into, which is not onto, that is into. Which function is not onto function is into, right? Example here, sine of x is 1, 1 or not? It is 1, 1 or onto or many one. अच्छा, साइन ऑफ की ग्राफ तो सबको पता है ना. If you will draw a horizontal line, it is intersecting the graph more than 1 point. That means it is not 1. It is not 1, 1 function. It is onto, because the codomain is given as codomain is R, right? Range is always, we know the range of sin x is -1 to 1. So here we are getting range is not equal to codomain, right? So it is not onto, it is one function. It is one function. It is not onto. Okay, clear everyone? I hope this is clear. Very simple thing we are discussing here. Okay, it is bisective or not? Homework. Let's take it as a homework. You can solve. Huh. This question also you can take it as your homework. These two questions, it's a homework question for you. You can take a screenshot also. You can make a note, and also then this is also one homework questions. One more homework questions. Okay. Let's take a screenshot or make it note. Okay. In the next class we will be discussing what is composite function, right? Next class में क्या discuss करने वाले हैं हम लोग? One is important, two things we will be discussing, that is one is composite function, and the next thing is what is that? Inverse function. Okay, composite function and inverse function we will be discussing in the next class. Okay, that's all for today's class. Thank you all. Bye bye. Take care, everyone. Anyone having any doubt, you can ask. Thank you all.